to the project. So guys, in this series, we'll be implementing one amazing end-to-end deep learning project. And again, I'm telling you guys, this would be the basics implementation because we just started with the implementation. So once we complete one basics implementation, then I will show you the advanced implementation with the help of MLOps tool as well. So I think you remember we already implemented one machine learning end-to-end project. There I already showed you one basics end-to-end implementation. Okay, so now in this series, we'll be implementing one end-to-end deep learning project. That means I want to show you how we can create the deep learning pipeline, because machine learning pipeline wise you already familiar with. So inside deep learning, I think you know we are having artificial neural network, that means ANN, then convolutional neural network like CNN, and recurrent neural network RNN. So ANN actually we don't use it usually. ANN is only for the understanding of the neural network. So whenever you'll be implementing any kinds of project, whenever you'll be solving different use case, so you have to use either CNN architecture, either you have to use something called RNN architecture. So here we'll be using CNN architecture to implement this entire project. That means here we'll be solving one image classification problem statement. Okay, and guys, make sure you complete the entire development with me. And after that, I believe you will be able to implement any kinds of deep learning pipeline. And no need to worry, I will also tell you how we can create advanced kinds of deep learning projects with the help of different kinds of MLOps tool as well. Fine. Even I will also show you how we can implement any kinds of object detection end-to-end projects, image segmentation end-to-end projects, NLP end-to-end projects. Okay, everything I will try to clarify. So first of all, I will start with one basics implementation without any kinds of MLOps tool. Then I will start with advanced implementation with the help of MLOps tool. Okay, this is going to be my entire agenda through the entire project implementation series. Now guys, let's talk about what would be the agenda of this series. So this is the entire agenda, guys. So definitely, first of all, I'm going to show you the project introduction, like which problem statement we're gonna solve. And see, here I can take any kinds of problem statement. It's not necessary to take my problem statement always. You can pick up any kinds of problem statement, any kinds of data set. Only you just need to change that data. Okay, you just need to change the data, that's it. So your problem statement will be changed only, but the entire pipeline will be common. Okay, inside all the implementation you'll be doing. Got it? Then I will be starting with the GitHub repository setup, project template creation, project setup, requirement installation. So these are the steps I think I already covered in my previous project implementation. So we'll be following the same technique, same project folder structure to implement this entire deep learning pipeline. But deep learning pipeline is slightly different than your machine learning pipeline. I'll tell you, okay, where actually we'll get the difference. That time actually you can understand, but we'll be following the same technique. Whatever, let's say, technique we followed to implement our machine learning project previously, that I think end-to-end wine quality prediction we develop, right? So same actually structure, same actually strategy will be following here also, right? So make sure guys, first of all, you complete that implementation, then you come here. Otherwise, it would be a little bit difficult for you to understand. Okay, so that should be my suggestion. First of all, complete that machine learning implementation, then come here. Then I'll be discussing about like logging, utils exception, project workflows, all component notebook experiment. I think you remember we did the notebook experiment for the all component. Then we have to do the all component modular coding implementation. Then we'll be creating the training pipeline, prediction pipeline. Even we'll be also implementing the user application. That means web interface will be implementing so that user can upload an image and they can get the prediction itself. Okay. Then at the last of the implementation, I will also show you how we can deploy this project. Okay. With a cloud platform with the help of CICD. Okay. CICD, that means continuous integration and continuous deployment. So here we are not going to follow the simple deployment. We'll be following the entire CICD pipeline. Now you can ask me what is the prerequisite for this deep learning project implementation. So here I'm also expecting you are familiar with Python programming language. At least you should have knowledge on OOP, that means object oriented programming. Then I'm expecting you are familiar with basics of deep learning, at least image classification. And you should have knowledge on TensorFlow 2.x API, because throughout the entire implementation I'll be using TensorFlow framework. Okay, and if you don't know, TensorFlow is a deep learning framework. With the help of that we can create a neural network. Okay, then you should have one AWS account, because whenever we'll be deploying the project, we'll be using AWS account. And no need to worry, I will also show you how we can use any different cloud platform. Okay, whenever we'll be implementing advanced kinds of project, that time I'll tell you. Then the last, super important, your dedication. Okay, so you should have your dedication, guys. So whatever things actually I'm doing, also try to actually practice with me, along with me, just try to write the code. Definitely, you will be able to understand each and everything. Okay, whatever I'll be explaining here. Now guys, let's come to the problem statement. So here we'll be solving one problem statement called chicken disease classification. Okay, so I think you know chicken is having actually different kinds of disease. So here actually I have collected one data from a website. I'll tell you what are the website you can follow to collect these kinds of data. So I collected actually some images from that website. So the image contains actually coccidiosis disease affected chicken. You can see this is the coccidiosis affected chicken. So this disease name is coccidiosis. Okay, coccidiosis. You can search on Google what is coccidiosis disease. So this is one kinds of disease affected by chicken. And to classify these kinds of actually disease, okay, of the chicken, what we'll be using something called chicken fecal image. Okay, chicken fecal image. You can see this is the chicken fecal, and this is the coccidiosis affected chicken fecal. You can see the color of the fecal is yellow. So if it is kinds of yellow, that time you can consider this chicken has been affected with coccidiosis disease. So guys, let me show you the data. I think you'll be able to understand, okay, what are the image actually we are using here. So guys, as you can see, this is the data I downloaded called chicken fecal image. Now inside that I'm having healthy chicken fecal image. So this is the healthy fecal. So you can see this is the healthy fecal. Okay. So the color is kinds of white and black. Okay. But if I show you the coccidiosis affected chicken fecal, you'll see that it's a yellow. Okay, it's a yellow one. Okay, so with the help of this fecal image, we'll try to classify whether this chicken has been affected with coccidiosis disease or not. So this is a classification problem statement we'll be solving. I hope it is clear. I will tell you where you can get these kinds of data and how you can download. I will tell you each and everything whenever we'll be performing the data ingestion part. That time I'll tell you. So I think guys, now problem statement is clear. Which problem statement we're gonna solve with the help of deep learning. Okay, deep learning technology. Now you can pick up any kinds of problem statement. Okay, it's up to you. So yes, this is the entire project introduction and overview. Now what we'll be doing, guys, we'll be creating one GitHub repository. That means we'll be setting one GitHub repository. Then we'll be starting our code implementation. But before that, we also need to set up our project. Okay, so let's create one GitHub repository. So guys, to create the GitHub repo, first of all, open up your GitHub repository. And here you can click on new repository and just try to create one repository. I'll name it as end-to-end chicken disease classification using fecal image. Okay, fecal image. Because here we are using chicken fecal image, right? Fecal image to classify the disease. Now we'll be keeping this as a public repo. I'll add the readme file. I'll also add .ktignore. That's a Python. I'll be using Python programming, and you can take any kinds of license. I'll be taking MIT. Yeah. So now let's create the repository. So once you create it, just try to click on the code, copy the link address. Now try to open up your local folder and open up your git bash here. And just write the command git clone, paste the link, so it will automatically clone the repo here. Then after that, I will go inside that cd end-to-end chicken disease. Now I'm inside this folder. Now inside that, I'm going to open up my Visual Code Studio. So let me open. So now the first thing, guys, I think remember we have to create the project template. Okay. And to create the project template, I will be using my previous project example. There, whatever template file I created, I'll be using the similar template. Only I'll be changing the name. Okay, that's it. So let's create the project template. Okay, so guys, to create the template, I think remember we have to create one file here called template.py. Okay, inside that we'll be writing the Python logic. And I think you remember we created one project called end-to-end one quality prediction. So there also we created the template.py. So let me open it up. And whatever code I have written, so I'll just try to copy. So make sure, guys, you check that implementation, because I'll be utilizing the same technology here. Then I'll be pasting it here, because I already told you there, na? So project folder structure is not a fixed. You can use any kinds of folder structure. It's up to you. Okay. So here I usually follow this structure whenever I implement any kinds of end-to-end projects. I'll also tell you some more project folder structure you can follow whenever we'll be implementing advanced kinds of project. That time I may also use any other template as well. Okay. As of now, just try to use the same template. Now here, instead of giving ML project, I'll give CNN classifier. You can also give chicken disease, but I'll share this project as a template. Okay, so that you can use this template in your every project. That's why I've given CNN classifier, because it will become one classification project, right? That's why you can give any name here. It's up to you. Now here, I don't need this schema file because this is the ML project file. Okay, I don't need it. Then I'll also try to remove this test.py. It's not required. Then I think you remember we also need to do CICD deployment. For this, I need this folder actually, .github/workflows. Inside that, I have to create one file called CICD.yml. But as of now, I'm not going to create the file. As of now, I'll create one file called .gitkeep. Okay, because I can't create the empty folder. Okay, inside that I should have some file. That's why I'm creating this. And going forward, whenever I'll create that CICD.yml, I'll try to remove it. So I think yes. So these are the file actually I need. Again, I'm going to use Flask here. That's why I need this template actually folder inside that index.html. All right. So as of now, these are the folders and file I need. If I need anything else, I'll just try to create later on. Now, what I have to do, I have to execute this file. So Python template.py. Now left hand side, you will see that it will automatically create the template for you. Okay. See, all the files and folder has been created successfully. Got it? See, you can also verify whether everything is created or not. Now let's do the commit. So you can also commit the changes from your git bash. So for this, just write git add. Now git commit -m folder structure added. Then git push origin main. Done. Now if I go back to my GitHub, you'll see that my folder structure has been added. Okay. So now let's do the project requirement setup. That means we'll be setting all the package actually I need to implement the entire project. So let's start with the setup. So guys, to set up your project, so you just need to specify all the package inside requirement.txt. Apart from that, you also need to set up the setup.py, because I also need to install the CNN classifier as my local package, because I think you saw in my previous project implementation, I was also importing, okay, from these are the folders and file, right? So that's why I also need to install these as our local package. CNN classifier would be installed as my local package, okay? That means I can install anything, let's say from CNN classifier .components import data ingestion. Okay, I think you remember my previous project, I also created one root folder called ML project. And there I was importing like from ML project .components import data ingestion. The similar kinds of, let's say, strategy will be also using here. So here, first of all, I need something called TensorFlow, okay? Because I already told you, this is a deep learning project implementation. So for this, we will be using TensorFlow. You can also use PyTorch. So going forward, I'll also, let's say, implement end-to-end project with the help of PyTorch. But in this implementation, we'll be using TensorFlow, okay? That's it. And whenever you're using these kinds of deep learning, machine learning library, try to also specify the specific version. Otherwise, what happens actually, see, these are the library actually changed frequently. Like they will update their code base frequently. And sometimes you may face any, let's say, dependency issue, error issue, right? So that's why always try to use one stable version. And 2.12 is the stable version of the TensorFlow. That's why I'll be using 2.12, this particular version. Apart from that, I also need, these are the library like Pandas, Notebook, Matplotlib, Seaborn, Python box, okay? Then I'm also importing Flask because we'll be creating the web application with the help of Flask. So yes, I think most of the library you are already familiar with, like what is Python box, what is Ensure annotation. If you're not familiar with, I'll again tell you, okay, I'll again explain, okay, why we're using it. Okay, here, everything I will try to clarify. So yes, guys, these are the library I need to implement this entire project. And what is this -space dot? Because we'll be also setting this setup.py, okay? And this setup.py will set up this folder as my local package. So let's also write the setup.py code here. So this is the setup.py, guys. Here you can see. So you can specify the version, then your repo name. So my repo name is, so this is my repo name. I'll copy and let's specify here. Okay. Then you can give the author name, then author email address, and this is the setup. So this setup will look for this constructor file and it will install this folder as my local package. That's it. Now let me save. And now let's install this requirement.txt. For this, I think remember, I first of all need to create the virtual environment. Yes or no? Because it's always recommended whenever you are creating any end-to-end projects, try to create one virtual environment. And to create the virtual environment, let me specify all the command you need. So guys, you can follow, these are the command. So first of all, if you're using my repository, just try to clone my repository. So you just need to clone this link, copy the link. Let me also mention it here. Okay, then after that just try to create one environment. So let's copy the command and try to paste on your terminal. So it will create one environment named CNN CLS, that means CNN classifier, with the help of Python 3.8. Okay, it's created. Now let me activate it. I'll copy this command and let me activate the environment. Then after that, let's install the requirements with the help of this command. So this requirement installation may take some time. Let's wait. Once this is complete, I'll come back. So guys, you can see requirement installed successful. There is no error. Now we'll be creating a very important actually component like login, exception, and utility. So let's try to create the login, exception, and utility. An exception I'm not going to create separately because we'll be using box exception. I think you remember we are using something called Python box package, right? So here you can see Python box package. So with the help of that, we can write the exception. Okay. So let's create the login. Then I will also show you the utility and everything. So guys, I think you remember to write the login. We are using this file, this constructor file, which is present inside my root like folder. That means my CNN classifier. And in case the machine learning, I was using this ML project. Okay, ML project folder. Inside that, we are having a constructor. So let's write the login inside this file. And I already told you if I'm writing login inside this file, so what would be the advantage? Okay, because I can easily import that. I don't need to write too many import operation. Okay, this is the main advantage here. So let me open this file and let me mention it here. So this is my custom log. Okay, I have prepared. So you can see this is the login string. It will create a log folder inside that running log.log file. And this is the final configuration. Okay, that's it. Now let me test whether this is working or not. I will open up my main.py. Let me import the log. So I'll just write, first of all, let me select my environment. Just right hand side below, you can see I have selected my base. Now I'll be selecting my environment, which is nothing but CNN classifier. Okay. Now I'll just write from CNN classifier. Now see, CNN classifier is suggesting because this package has been installed as my local package. Import logger. Now simply just write logger.info. You can give any message. Let's say welcome to CNN classifier. Now if I execute this line, Python main.py, you'll see that log folder has created inside that running log. Now see, this is the log. First of all, it will say my current timestamp, info level log. This is running from main.py, and this is the log message. Okay, I hope it is clear how log is working. Okay, now let's write the utility. So inside utils, I'm having the common.py, and inside that I'm going to mention all of my utility related function. And I think you already know what is utility function. That means the function will be using frequently inside our component. Instead of writing them again and again, we can keep inside utils folder, and whenever we need it, we can import it. In my machine learning implementation, I already clarified this part. Now you can see I'm using the same functionality like read YAML, then create directories, save JSON, load JSON, okay, save bins, load bins, get size. So what I told you, whenever I was implementing that project, what I told you. So the same structure you will be using in your every project. Okay, now I think you can believe me. If I can implement only one structure, I can use this structure to implement any kinds of project. Got it? And I will also show you different kinds of structure as well. If you need it, I will also show you. No need to worry. So two more actually function I have added here. New function, decode image and encode image. Why I kept this decode and encode image, I'll tell you. Whenever we'll be creating the web application, that time I'll tell you. Because the user will upload the image in my web application, right? And we can directly get that image in the backend. So first of all, we have to encode this image. Okay, then we have to decode this image. So we'll be using base 64 for this, base 64 string. I'll tell you whenever we'll be implementing this, that time I'll tell you. As of now, just try to consider this part I need whenever we'll be doing the prediction. Okay, we'll be creating the user application, that time we need it. Got it? And see, otherwise everything is same. Okay, everything is same. And again, if you want to understand like what is Enchant annotation and what is config box, no need to worry. I will add the video actually I recorded previously in that project implementation. So this video I'll just try to add here. So this video will give you the entire understanding, like what is entire annotation and what is this config box. Okay, why are we using with all of my function. Okay, so let me show you this part actually, why this ensure annotation and config box is required. So for this, what I will do, guys, I will open up my resource. So you can see there is a resource trials.ipynb I have created. So inside these trials, we'll be doing the experiment. Like we'll be learning why we're using this at the functionality. Okay, these are the thing. Now let me first of all select the kernel. So Python environment, I'll be selecting my ML project. Okay, it's fine. Inside that, first of all, I'm going to create so inside this resource folder, I'm going to create a YAML file. So let's say I'll give it as test.yml. And inside this YAML, I'm going to write some content. Let's say, first of all, I'll write the name. Let's say Buppy. Then I will also write the email. Let's say I'll add my email. Okay, now this YAML file I'm going to read from this notebook itself. For this, you can use this code snippet. So there is a package called YAML inside Python. We already installed YAML, I think you remember. So with the help of YAML, you can load this YAML. So this is my location of the YAML file, test.yml, you can see. And I'm opening this YAML file, then I'm loading with the help of safe load function, okay, inside YAML. Now, if I show you the data, whatever content it is returning. See, if I execute, see, whatever content I have inside the YAML file, it is returning. And if you see the type, of this data, it's nothing but it's a dictionary. Okay, it's a dictionary. That means by default, if you're using any YAML file, if you're reading something, any content from the YAML file, it will give you dictionary, output, dictionary data type output, right? So now if I want to, let's say, extract the name, so what I have to do, guys, I think you know how to play with the dictionary, how to let's say access any element inside a dictionary. For this, we have to use the key name. So what I will do, I'll just write data. I'll give this square bracket. Inside that, I'll pass the key name. Let's say name. Name is my key, and it will give me Buppy. Similar ways, you can also extract the email. Okay, email. So it will give you email. Okay. So every time I just need to define the square bracket. Inside that, I have to give the key name. But can I call like that? Let's say if I just write data dot name. Can I call like that? If I execute, will it work? See, it won't be working. It will give me error. That means this object has no attribute name. But this actually syntax is more convenient than this syntax. I don't need to write square bracket. I don't need to write double quotation. I can directly specify the key name and I can get the value, right? But it's not happening here. So for this, we'll be using something called config box. Okay. So config box will give you this kinds of functionality, so that you can get these kinds of output. Let me show you how it can be done. So first of all, let's import this config box from the box. So box import config box. So inside config box, okay, you have to pass the data object, whatever data object actually you got after reading the YAML file. Okay, so it will give you, let's say it will give you the data D. Okay, now see if I execute. Now, if I show you the D, now you can see it's a config box type right now. Now I can easily call the name. Okay, d.name, so it will give me name. And if I call d.email, it will give me the email. Okay, that means if you want to call like that, you can do it with the help of config box. Config box will give you this kinds of ability. And this is like more convenient than this one. Okay, so this is a new package. That's why I thought let's also show you how we can use them in our implementation. With otherwise, if you're not using it, it's completely fine. But every time you need to call like that. Okay, that's why I thought let me show you this one as well. So that whenever we are reading any kinds of YAML file, so that we can, let's say, return all the, let's say, content as a config box type output, so that we can extract like that. Okay, I hope it is clear now. Now let me show you the next one, which is nothing but ensure annotation. Why ensure annotation is required? For this, let me show you another example. So ensure annotation. So let's say here I'm having a function. The function name is getProduct. So it takes two numbers, x and y. Both are integer type, and it will give you x times y. Okay, this is the product function we have created. Now, if you pass any value inside that, so it will give you the product yes or no. Let's say x is equal to 2, y is equal to 4, it will give you 8. But if I pass like that, let's say x is equal to 2, y is equal to string of 4, will it work that time? Because here you have mentioned integer, but here you are trying to pass string. Now, see if I execute, still it will work. Okay, still it will work. It is giving me 44 because it is multiplying this integer with the string, and that means it is repeating this string that number of time. That means 2 times. You can see 4, 4. Okay. So let's say you have written a very big project and you are getting this kinds of unexpected output. That time you will go mad. Like, what is happening in my code? It is not giving me error, but you are getting unexpected output because of that. Because here you have already said it should be integer, but still you are able to give the string type input. Okay, it's not actually fair, right? So to overcome this issue, actually we can use one package called ensure annotation. So inside ensure, we're having the ensure annotation functionality. So let me import it. Then whatever function you have written, only you just need to add that decorator. Okay, so ensure annotator decorator on top of the function. Okay, now see what will happen. Now if I try to give the integer, it will work, but whenever you will try to give the string, it will throw you error. So it is throwing error. Argument y type class string function object does not match annotation type class int. That means here it is expecting integer type, but you are given the string type. Okay, that's how we can fix this kinds of small error, and we can make our code more robust. I hope it is clear now. So guys, I think you saw like what is ensure annotation and config box. And for exception, I think you can see I'm using box value adder. That means box library I'm using. You can also create custom exception if you want, but I'm going to use this library itself. Okay, that's it. So yes, we are done with our utility exception and this one login. Now I'll show you the project workflow. Okay, like which file you have to change first, which file you have to change last. So guys, as you can see, this is my entire project workflows. So first of all, we have to change the config.yml file because it will contain all of the configuration, all of the variable. Then if you have the params, so you also need to update the params because here will be updating all the model parameter. Then entity, so you can see we're having one folder called entity. Inside that config entity we have to change. Then configuration manager inside src config, so inside config we're having configuration.py. Then component, so you can see component, so here we'll be adding different component like data ingestion, then PrepareBaseModel, model trainer, model evaluation. These are the component we'll be adding. Then pipeline, so if I want to execute the component, I need the pipeline. So for this we'll be creating the pipeline, stage-wise pipeline. Then we'll be updating the main.py, which is nothing but my endpoint. Then we'll be updating the app.py, which would be our application. Okay, application endpoint. So this is the entire project workflow. So we'll be following whenever you will be updating the code, just try to follow this workflow. It will be easy for you to update the code. Got it? So yes, now what we'll be doing, guys, we'll be doing our data ingestion component. First of all, we'll be doing in our Jupyter notebook. First of all, we'll try to I'll try to show you the entire Jupyter notebook experiment. Then I'll try to convert this notebook as one modular coding. So guys, now let's start with our data ingestion part. So first of all, what I will do, I'll just show you the notebook experiment. Then I will try to convert this notebook to our modular coding implementation. Okay. So for this, inside this resource folder, I'm going to create another file called, let's say, 01 data ingestion, because this is going to be my first stage. So that's why I'm giving like number. You can also skip the number. You can give any kinds of name. It's up to you. But whenever you are creating the pipeline, just to remember what you can do, you can assign the number. Okay, that would be better. Data ingestion.ipynb. So this is going to be my notebook file. So first of all, let me select my kernel. So this is my kernel, cnncls. Yeah. So the first thing, guys, what I have to do, I have to get back to my project working directory, because if I show you, let's say if I just write this command, first of all, let me import operating system. Now see if I do pwd, you'll see that I'm inside resource folder. Okay. But what I need to do, I need to get back to my project folder working directory. So this is my project folder working directory, but I'm inside this resource folder. Okay. Now if I want to get back, what you need to do, I think remember in our previous project also I showed you. So you have to use this command. So os.change directory. So inside that you just need to write dot dot, okay, slash. So if you give dot dot slash, it will automatically get back one folder. So let me show you now. See my project working directory, my root directory. So I think you remember the workflow I told you. First of all, we have to update the config.yml, then entity, params. As of now, I don't need, because params will be updating whenever we'll be doing the model configuration. But at the very first, you have to keep some dummy value in the params.yml. Otherwise, you will get some issue. Okay, whenever you will execute the code. So make sure this file is not empty. Okay, you just add some dummy value as of now. Then components, pipeline, main, okay, and so on. But before that, let me show you like the data. I think you remember we collected this data called chicken fecal images. Okay, now you can ask me from where we can get the data. So simply you can go to the Kaggle website. So Kaggle, or you can directly search chicken disease dataset Kaggle. So you will get this kinds of image actually. See, so this is one of the data you can use, and you can see inside training, we are having this image. Okay, and see, this data contains actually multiple classes like coccidiosis, then salmonella, then you can see Newcastle disease. Okay, so that's how actually it is having multi classes. What you can do, you can download the entire data and you can create a multi-classification model. Okay, only just you just need to change the last layer of your neural network. Then you can create a multi-class classification. I'll tell you whenever I'll configure the model. That time I'll tell you if you want to perform the multi-classification, that time how you can perform it. So here we are doing actually it's a binary classification. So healthy or coccidiosis. Okay, that means we are having two classes. Okay, but if you're having more than two classes, that time you can perform multi-classification as well. Got it? So here what I did, guys, I already downloaded the image and I collected this coccidiosis actually fecal and healthy fecal. Okay, so these two images actually I have collected. Now there is another website you can refer called RoboFlow. RoboFlow is having one amazing product called Universe. So just let me open the Universe. Universe is having all kinds of computer vision related data. Let's say you want to perform classification. Just click on the classification and simply search here. Let's say you can simply copy from here. You can search chicken disease. Okay, so it will also give you chicken disease kinds of data. So guys, you can see chicken disease detection and tracking. So they're also having classification kinds of data. Okay, if you just find it here, okay, if you find it here, you will also get classification data. So in case actually what I did, I just downloaded the data from the Kaggle website. Okay, so you can also download from the Kaggle, and I will also share my data with you. I'll share you my URL. From there you can also download my data. Okay, that's it. So the first thing what you have to do, you have to upload your data in your GitHub, because I already told you this is the basics implementation we are doing at the very first. So we'll be trying to read the data from the GitHub itself. Okay, later on I will also show you how we can read the data from this 3 bucket from the database. Okay, and this is the image data. Okay, it's the image data. So this data actually we can't store inside a, let's say, database. Okay, so in case if you're having image data, so what you can do, image videos data, you can keep inside this 3 bucket storage service you can use. So you can use AWS, GCP, or you can also use Azure. So from there actually you can read the data. So you can create a bucket, inside that you can keep the data. So as of now, if you see my data size is very less. If I show you my data size, if I show you the zip file, so this is the zip file. So if I show you the properties, you can see it's around 11 MB. Okay, so if I'm having actually less than 50 MB, that case actually what I can do, I can upload the data directly to my GitHub. You can also upload in your Google Drive. From Google Drive itself, you can also read the data. I will also show you in some project how we can utilize our Google Drive, because Google Drive will give you free spaces. And at the end of the day, you have to reduce the cost also, right? So that's why we'll be utilizing free services most of the time. So GitHub also provides actually some kinds of free storage. So there actually I can also store my file. So what I've done, guys, I just uploaded this chicken fecal image inside my GitHub. So you just need to drag and drop. Okay, just try to make a zip file and drag and drop. Now see, it will automatically upload this file here. And if file size is big, it will give you error. Okay, you can't upload. That time actually you can keep you can keep your data in a storage service, or let's say Google Drive, there I can keep. So as of now, I'll just try to cancel. Once it is uploaded, just try to do the commit operation. I'll just cancel it because I already have the data. Let me show you. So chicken fecal image zip file. Just click here, try to copy the link address. Okay, right click and copy the link address, and this is the entire URL of your data. Okay, now you can see the first stage actually we'll be doing. So we'll be utilizing this URL to ingest the data. Okay, first of all, we'll be doing on the notebook, then we'll try to convert as our modular coding. Now before that, I think you remember we have to first of all update the config.yml file. And what is config.yml file? I think you already know. So here we keep all kinds of changeable variable. Let's say the variable I can change later on. Okay, that kinds of variable I can initialize here. So this is my data ingestion related variable. You can see. First of all, we'll be creating one root folder called artifact. Inside that, it will save all the artifact. It will create a data ingestion folder. Inside that, it will ingest the data. That means it will download the data from this URL and it will save inside the folder. Okay, So these are the configuration you have to write inside config.yml. And this is the entire data URL, guys. Okay, the data URL actually you have copied, you just need to paste here. And make sure you are uploading data in your GitHub. Okay, sometimes actually if you are trying to download from my GitHub, you might get some error. So make sure you are uploading inside your GitHub and try to replace the link. Okay, that's it. Now you can see, guys, these are the variable I need, okay, for the data ingestion. Now let me save. Now the second thing what I have to do, guys, I have to also set the path. Okay, like I will be reading this YAML file. Okay, so I also need to set the path inside constant. So from constant, actually I'll be returning two paths. One is the config file path and this is like param file path. Okay, this two file path actually I'll be returning so that I can read it later on. Okay, with the help of read YAML functionality. I think you remember inside common we have already written read YAML. Okay, this will read the YAML file and it will return the content. Okay, I hope it is clear. Okay, fine. So guys, now let's open up our notebook. Now the first thing will be updating the entity. So I think you know what is entity. Entity is nothing but it's a return type of function. So this is the entity. That means whatever variable I have defined here, the same variable I'm initializing it here. Okay, and I'm also giving the data type. Okay, like root directory is a path, then source URL is a string. Okay, that's how you can also give the data type. And this is a data class because it will return these are the variable. Okay, so you don't need to write the self here because it's not an actual Python class, it's a data class right now. Okay, and frozen is equal to true. That means apart from that you can't define any other variable. Okay, these are the frozen already with that. Now let me initialize the entity. Now the second thing, I have to update my configuration manager in src config, but here we are doing inside notebook. So let me write everything in the notebook. So for this I need these are the library. So you can see I'm importing constant. That means whatever constant I've initialized here. So here the constant I've initialized. So this will give me actually two variables. So this two variable actually I'm importing here. I'm giving this start. That means it will import everything inside that. Then from common I'm importing read YAML and create directories. Okay, these two functions. Now you can see this is my entire configuration manager class. So here I've written a configuration manager class. Inside that I'm reading the YAML file. You can see that config YAML file and params YAML file, both I'm reading. But params YAML file is empty. Okay, if you see it's empty, so I have to add some dummy value. So here I can write key val like that. So later on I'll change it whenever I'll initialize the model. As of now, let's give the dummy value. That's it. Now first of all we'll be creating the directory, that means artifact root. Okay, that means this artifact folder would be created. After that I'm initializing one method. The method name is get data ingestion config. So the return type is data ingestion config, the same entity we have I think defined. I think remember. That means it will return only these are the variable, and these are the variable actually value from where I'm getting from the YAML file. I think you remember. Okay, from YAML file actually I'm getting it. So you can see I'm initializing the YAML file. From that YAML file I'm reading root directory, source URL, local data file, zip directory. Okay, that means whatever value we have assigned here. Okay, everything we're trying to read. And how we are reading, I think you remember, it is returning the YAML file, and that YAML file we are returning as a config box. Okay, and we can call these are the key like that. I think you remember that trials.ipy when I showed you now how we can convert dictionary to this one config box type format. Okay, now let me initialize the configuration manager. The next thing I'll be creating the component, our actual data ingestion component. For this I need these are the library. I'm using a request library. So with the help of request we'll be downloading the data from the GitHub. Okay, then logger and get size. Get size, it will give you the size of the data. Now this is the entire component class, like data ingestion class, guys. You can see. So here it will take one input called data ingestion configuration. That means the configuration you have created, it will take the configuration. After that, this is the method. First of all, it will download the data from the URL. You can see it is downloading the data from the GitHub URL. Okay, then it will logging the information. Then after downloading, it will extract the zip file, because first of all I have to download the data, then I have to extract the zip file. And to execute this method one by one, stepwise, so we have to use some pipeline. Okay, so you can see the next stage is the pipeline. So let's update the pipeline. So pipeline is nothing but it's a step of execution. So you can see this is the entire pipeline I've written. First of all, I'm initializing the configuration manager because I need this configuration, right? Then I'm getting the configuration. You can see get data ingestion configuration, and whatever configuration I'm getting, I'm passing it to my component class. You can see, okay, because it will take that. Then I'm calling the download file first of all. Then I'm calling the extract zip file. Okay, second, because first of all download, then unzip. Okay, I think it is clear now. Now see, if I execute this program, you'll see that left hand side your data would be ingested. See, it is downloading the data right now. So guys, as you can see, execution is completed. Now if I open the artifact, now it has created data ingestion folder. Inside that you can see it has downloaded the data zip file, and it has also unzipped it, and you can see this is the unzipped data, and inside that you are having coccidiosis image and healthy image. That means we have successfully ingested the data. Now what we'll be doing, guys, this notebook is working fine. Now let's try to convert this notebook as a modular coding implementation. So guys, now we'll be writing the modular coding, and trust me guys, if you have completed the notebook, so writing modular coding is very easy. So only you just need to copy paste the code from your notebook itself. So let's do it. So first of all, I think remember update the config and params. This is already updated. Now let's create the entity. So you can see I have created an entity folder. Inside that config entity is there. So let me open it up, and whatever entity you have created in the notebook, just try to copy paste the same one. So let me copy, and here let me mention it. So let me close these other tabs, not required. So I'll paste inside that and I'll save it. Make sure you save, okay, with the Ctrl S. If you are not using actually autosave inside VS Code, just try to save the file first of all. Then the next thing, I just need to update my configuration manager in src config. Okay, so you can see inside src we are having config. Inside that configuration.py. So let me open it up. So whatever code you have written here, just try to copy. So this is my configuration. Now I also need to import this data ingestion config from where? From the entity itself. I think you remember inside entity we created this particular, let's say, class. Okay, now let me import here. So from CNN classifier dot entity dot config entity import data ingestion config. Fine. So let me check. Yeah, everything is fine. Now the next thing, I have to update my components. So let's update the component. So inside this component folder, I'm going to create a file called data_ingestion.py. So whatever, let's say this one component we have written, just try to copy paste. I'll copy this class as it is, and here I'm going to paste it. Okay, now if anything is missing, so path is missing, so let me import the path. So from pathlib import path. Then I also need this data ingestion config. So from CNN classifier dot entity dot config entity import this data ingestion config. Okay, so I think everything is fine. Now the final thing, we have to create our pipeline. That means if I want to execute the component, definitely I need the pipeline. So to create the pipeline, I'll go inside pipeline folder and let me create a file called stage01 data ingestion.py. Okay, this is going to be my first pipeline. And I think you remember pipeline we created in the notebook. So the same pipeline will be also writing here. So I need the configuration manager and component. Okay, this two class, so I need to import it. So let me import all of them. You can see I'm importing configuration manager and data ingestion component. Okay, from the component and as well as the configuration. And this is the logger. Now, first of all, give me the stage name. So this is the stage name, data ingestion stage. Now this is the final class I have created called class data ingestion training pipeline. Constructor would be empty. I'm not doing anything. And inside main method, whatever code I have written, I just copy pasted. See, the same code I've copy pasted here. First of all, it will initialize the configuration manager, getting the data configuration, then passing it to the component and calling the method download file and extract zip file. Okay, I think we remember. So here it's done. Now let's add this pipeline inside our endpoint, because we'll be executing the endpoint and my application would be running. Okay, so main.py is my endpoint. So let me just write that one. First of all, let me import this data ingestion training pipeline from the stage 01 data ingestion. That means from the pipeline we are importing that class. Then after that, this is the final code. So it will call the main method. I'm initializing the data ingestion pipeline. Then I'm calling the main method. And if I'm calling the main method, that means it will execute and it will start the pipeline. Okay. So let me open it up. Yeah. Then I'm also logging the information like our data ingestion started and when it is execution is completed and it is ended. And I'm running inside try except block. Let's say if some exception is going on, it will also show you the exception block as well. Okay, that's it. Now, yeah, so I think it is ready. Now let me delete that artifact folder and let me try again. So can delete. Now open up your terminal. Make sure you have activated your environment and just write python main.py. So guys, as you can see, execution is completed. Now if I open the artifact, so here you can see data.zip file and this is the unzip file. That means everything is working fine. Now let me commit the changes. So you can see it is also committing my artifact, but I don't want to commit the artifact. So I can add the artifact inside my .gitignore node. So inside that you can add. If you don't want to commit anything, you can add inside artifact. Now you can see artifact has been removed. Now simply you can commit the changes from your VS Code as well. So here I can give a data ingestion added. Okay, now if I go to my GitHub and refresh, you'll see that this commit has been added. Okay, so yes, that's how actually we can perform the data ingestion. And now I think you got it. Okay, how to perform the data ingestion. And not to worry, I'll also tell you how we can read the data from the storage service as well, like bucket. We'll be also using bucket in future. Now the next test we'll be doing the PrepareBaseModel. That means we have to prepare our base model. We'll be using one pre-trained model. Okay, pre-trained model of the image classification. So I'll tell you what are the models are available. So guys, now let's prepare our base model. So guys, our data ingestion component is ready. That means we are able to ingest the data from the URL. Now the next component we'll be writing called PrepareBaseModel. So as I already told you, so here we are doing actually deep learning project. That means image classification project. And we already know, like inside image classification, we are having some pre-trained models. So if you want to see them, so simply go to the Google and you can search for Keras application. So here is the model list actually we are having inside image classification, and these are the pre-trained model. Okay, so this model is already trained with ImageNet dataset. So we are having exception, which is in 16, 19, ResNet 50. Okay, so these are the model we are having. And you can see the model size as well, model accuracy, then parameter size, okay, then the speed of the CPU, GPU. So everything is available here. So here, what I will do, guys, I will use one pre-trained model called VGG16. Now you can ask me why I'm taking VGG16, because if you have already worked with image classification, I think you know there are some architecture that will work actually better with most of the use cases. Like VGG16 is there, 19 is there, ResNet 50 is there, okay, then Inception is there, then efficient net is there. So these are the model actually works better with any kinds of problem statement. So that's why I'll be starting with the VG16, because it would be a little bit lightweight model for me. You can also take any bigger model. You can take Inception model, you can also take ResNet model. It's up to you. Okay, you are feel free to use any kinds of model. It's up to you. So I'll show you how we can use the VG16 model, because if I show you one model only, you can use any of the model. Okay, so now you can ask me how to use this model. So you can simply open this link. So they have already given the code snippet, like how we can call the model. Okay, so what are the parameter actually it is having. So what is the, let's say, input dimension. So everything they have written. You can see the input tensor. Input shape. It takes actually 2 to 4, comma 3. Okay, this is the dimension of the image. Now you can see it is also having the pooling parameter, classes parameter. So I don't need all the parameter. I'll be changing some of the parameter. I'll tell you. So these are the parameter we'll be writing in the params.yml file. I think you remember. Okay, great. So now see what we are gonna do here. Let me just try to explain in my Blackboard. So for this, what I have done, I have just taken this VG16 architecture. So I think you already know how to create this like custom architecture, okay, of any convolutional neural network. So these kinds of architecture, I think you are already familiar with, I'm expecting. So now let's try to understand what are we gonna do here. See, here we'll be using the pre-trained model. Pre-trained model means we'll be using the pre-trained weights. So you can see this is the convolutional layer. So till here, this is called actually convolutional layer, conv layer. Okay, and here you can see another layer. So this is called actually ANN layer. Okay, artificial neural network, or you can also talk about dense layer. Got it? Dense layer. So what we usually do whenever we use any kinds of pre-trained model, we don't train this particular layer. Okay, this particular layer we don't train. So this will remain same. So we are not going to do anything. What we'll be doing, we'll be only changing this particular part. Okay, this part. That means we'll be removing this last layer. Okay, because last layer you will see the classes actually they're using, it is 1000 classes. Okay, the last layer, their number of classes they're having called 1000 classes. Why? Because they have trained with ImageNet dataset. And ImageNet dataset, how many classes it is having? 1000 classes it is having. But for me, how many classes we are having? Only 2 classes we are having. Yes or no? That means that coccidiosis affected fecal and that healthy fecal. That is 2 classes we are having. So what we have to do, we have to change the last layer with the help of our number of classes. So this is the idea of our image classification. Yes or no? Right? So this is what actually we'll be doing. That means we'll be using the pre-train architecture, but at the last layer we'll be removing it. That means the ANN part will be removing it. Then we'll be creating our custom layer there with the help of our number of classes. And we'll be only training this part actually. This part will be training because this part is already trained. So it is already having like so many information. But if you also want, you can also train. These are the part. If you let's say I want to train this layer, you can also train. I want to train this layer, you can also train. Okay, I'll also give the functionality in my code so that you can also pass like how many layer you want to train. Everything it is possible. So now let's try to see how it can be done. So first of all, we have to get that VG16 model from the Keras. Then we'll be saving this architecture. Okay, in our artifact directory. Then after that, we'll be creating our custom architecture. Then we'll be merging together. Okay, this is the idea. So let's get back to my code. So this is my VS code. So what I will do in the resource folder, I'm going to create another file. I'll name it as 02 underscore prepare base underscore model. Okay, so first of all, let me select my kernel. Then I'll be executing the same code, I think you remember. Just to get back my project working directory. So let's copy and let me execute them. If I show you my project working directory, you can see I'm inside resource folder. Okay, so there is an error. It is telling pw not command enable. Okay, so if it is not working, you can give this % symbol. Now I think it will work. Yeah. In case if this exclamation mark is not working, you can give % symbol. Okay. Now I'll copy this one. Execute. Now if I again show you, I'm inside my project working directory. Okay. Now first of all, what I have to do, guys, I have to first of all create my configuration, because as per the workflow we know that first of all you have to update my configuration, then params, that entity, and so on. Okay. So let me first of all update my config.yml. So inside that I'm going to mention my PrepareBaseModel related configuration. So this is the configuration. So here it will create a folder called PrepareBaseModel inside artifact. First of all, we'll be like saving the base model. That means the VG16 model will be downloading from the Keras application. Okay. Then we'll save inside the artifact folder. We'll save inside the artifact folder. After that, we'll change the last layer. Okay, we'll be changing that particular dense layer with our custom architecture. Then we'll be merging that model, and this is going to be my base model updated.h5 model. And if you're using Keras TensorFlow, you have to save the model in a .h5 format. So yes, so this is what actually we have to write. Now the next update we'll be doing inside params.yml. So let me open the parameter. See, inside params.yml, you have to mention all the parameters you will be using in the model. So these are the parameter I'm going to update here. So these are the frequently changed parameter, guys. That's why I'm keeping inside params.yml. You can see. So here you can see, guys, I have written augmentation is equal to true. So Keras also provides augmentation functionality. Let's say you want to perform the data augmentation in runtime. It is also possible. If you are making it true, that means it will perform the data augmentation in the runtime. Otherwise, it won't be augmenting if you are giving it false. Then image size. Image size is a model parameter. You can see. So it is having the image size. That means input shape. Okay. That means this input shape of the image. It is accepting 224, 3. So this is what actually I have written 224, 3 as per the VG16 model. Now you can open up any other model and you can see the input size of that model. Okay. Then the bash size include top. Okay. Then number of epoch, classes, weights, learning rate. So these are the parameter we are already having here. You can see. Okay. Now why we are keeping this weight is equal to ImageNet? Because I want to download the pre-trained model, because it is already trained with ImageNet dataset. That's why we have to give this parameter. So it will give me the pre-trained model. Okay. Now, anytime you can open this file, you can change these are the parameter with respect to your requirement. Okay, that's why we are keeping everything in the params.yml file. Now let me save. Now I'll get back here, then I'll create the entity. So I think remember we have to create the entity. So this is my entity, guys. You can see I'm like initializing all the, let's say, configuration as well as the parameter. Okay, you can see like params, image size, learning rate, include top, weight, classes. Okay, whatever actually I need, I'm initializing it here. Now let me initialize them. Then I'll be writing the configuration manager, I think remember. So after that we have to create the configuration manager. So for this I need, these are the import operation. Now this is my data PrepareBaseModel related configuration. So here I've created a class. This is my constructor. So here I'm reading the config file as well as the params file, and here I'm updating all the variables. You can see. So from params actually we are updating for the parameter, and for configuration we are updating for the configuration. Okay, that's it. Then we are returning it. Now let me execute. Then we'll be creating the final component. So PrepareBaseModel component we have to create. So let me import these are the library. So here Keras is already available inside TensorFlow. That's why you are importing TensorFlow. Now let me show you one final class I have created for the PrepareBaseModel. See guys, this is the class. So those who have worked with actually Collab notebook before, so see the same code I have written inside a class only. That's it. Now you can see this is my class PrepareBaseModel. Inside that I'm having one constructor, and this takes actually the configuration. After that, first of all, I'll be getting the base model. Base model means we'll be downloading this VG16 model, okay, from the Keras application. You can see this is the syntax. So the same syntax actually I'm using. Okay. Then I'm passing the parameter and all. Instead of hard coding, I'm taking from my parameters. Okay. That means from my configuration. Then after that, I'm saving the model. And how to saving the model? For this, I've created a function here. So here's the function, guys. Save model. So it will take the model and it will save that particular model in the H5 format. Okay. And this is static method because here actually whenever you are calling this function, you don't need to provide the self here. Okay. Because what is static function? Static means this function can be used by any other, let's say, class. Okay. There is no issue. So after getting the base model, I'm preparing the full model. That means now user has the functionality. So user will pass the number of classes they are having. So they want to freeze all the layer or not. Let's say if I want to freeze all the layer, it will freeze all the layer. But if you don't want to freeze all the layer, you can mention like how many layer you want to freeze. Let's say you want to freeze till here. Okay, till here you want to freeze, and these are the layer you want to train. So this particular number you can give here. Let's say you have given 5. So what will happen? Till 5 layer it will freeze. So 1, 2, 3, 4, 5. So till here actually it will freeze the weight, and rest of the layer it will perform the weight update. Okay, during fine tuning. So this is what actually you have. Now learning rate, now you can see I'm preparing the full model. That means I'm changing the last layer, you can see gens layer, and number of classes I'm providing, and I'm giving the softmax activation function. Then after that, I'm compiling the model, because you know that if you're using Keras, so you have to compile the model. And this is my full model summary. After that, I have to update my base model. That means the model actually I have prepared. This model actually I have to update, I have to save. So this is what actually we are doing here. You can see I'm saving the model. Okay, inside my artifact. Now this is the class I have prepared. Now let me show you how it will save the model. So for this, I'll call my pipeline. So this is going to be my pipeline. You can see this is my pipeline. So I'm getting the configuration, calling the component, inside that passing the configuration, get the base model first of all, then update the base model. Now see if I execute. So first of all, it will download the base model, VG16 model from the Keras application. Then after that, it will update my model. That means it will remove this part and it will add my custom layer. That layer actually I have added. So guys, as you can see, my execution is completed. Now if I open the artifact folder, now it has created another folder called PrepareBaseModel. Now if I open it up, you'll see that it has first of all downloaded my VG16 model. That means my base model, and this is my updated version of the base model. That means this is the model actually will be using for my training operation. Okay. Yes, so great. It is working fine. Now let's try to convert this notebook as our modular coding implementation. Okay, so now let's try to convert this notebook as our modular coding. For this, first of all, I have to update my entity. So let me open up my entity. So inside SRC CNN classifier, entity is there. config entity. So let me copy. This is going to be my entity. I'll copy. And here, let me paste. Okay, so now I'll update my configuration manager. Okay, inside src config, because you think you already know. Just try to see this workflows. I think you will be able to understand, okay, what I'm doing. Now let me copy this method as it is, and inside that, inside my config configuration.py, after data ingestion, I'll try to mention it. Now let me import this PrepareBaseModel as well. Anything else I need? No, I think everything is fine. Okay. Now the next thing, I'm going to update my component. So let me copy. So inside component, I'll be creating another file called prepare_base_model. I'll copy the entire class. Okay. Apart from that, I also need to import path. Okay, path library. So from path lib, import path. Then I also need to import my PrepareBaseModel configuration from entity. So let me also import. So from CNN classifier.entity.config entity, import this PrepareBaseModel configuration. So anything else I need? Let me just check. No, everything is fine. Now let's update my pipeline. So inside pipeline folder, I'm going to create another stage 02 prepare base model .py. So this is going to be my pipeline. Okay, so I'm importing the configuration manager PrepareBaseModel component logger, stage name PrepareBaseModel, getting a constructor, but I'm not doing anything. That's why I've given the pass, and this is the pipeline, the same pipeline I've written here. Okay, I just copy pasted. That's it. Now this is I need to call inside my endpoint. So main.py. First of all, let me import PrepareBaseModel training pipeline. Then let me initialize the method. So you can see I'm calling the main method from the PrepareBaseModel. Okay, and main is the pipeline. So now I think everything is fine. Now let me test whether it's working or not. I'll delete the artifact. Now let me open up my terminal. I'm going to execute main.py. So first of all, it will ingest the data, then it will prepare the base model. So execution is completed. Now if I open the artifact, data ingestion is completed and PrepareBaseModel. See, everything is working fine. Now the next stage actually will be starting with the model trainer part. So guys, now let's start the model training part. So for this, I'm going to create another notebook inside resource. I'm going to name it as 03 model trainer.ipynb. So let me close these at the tab. It's not required. So the same code I'll just copy paste just to get back to my project working directory. I think remember. So now I'm inside my project working directory. Then let's try to add my config.yml file. So this is going to be my model trainer. So it will create a folder called training. Inside that, it will save my trained model. Okay, this is the idea. Now let's create my entity here. So this is my entity, guys. You can see I'm initializing all the variable. Apart from that, I'm also initializing some parameter from my params.yml. So here you can see some of the parameter actually I need for the training. That means I need the number of epoch, batch size, augmentation. Okay, then image size. These are the parameter I need during training. So let me initialize them. Then I'll be creating my configuration file. That means inside src config we have this configuration, I think, remember. Okay, configuration manager we have to create. So let me import these at the library, and this is my configuration manager. So the same thing, only the change you have to do here. So whatever variable you initialize, you have to return them, okay, one by one. Okay, it's done. Now let me create the final component. So this is my training component. See, if you have already worked with TensorFlow Keras, I think we know. Inside TensorFlow Keras, we already have the functionality related train validation generator. So instead of converting your data to training and testing set, previously what you can do, you can use this Keras functionality to do it. Okay, so I'm using the Keras functionality. First of all, I'm getting my base model. So it will so this function first of all load our base model. Okay, so base model means our updated base model. So this model actually it will load, because this model I'm going to fine tune. Yes, then I'm going to generate my training and validation data. So this particular function will generate my training and validation data. Okay, from where? From the image directory. So image is present inside this data ingestion. So it will load these are the data. Okay, and it will give me training and validation set. Okay, and it will also perform some augmentation technique, I think you know, like rotation range, horizontal flip, because here we have given the augmentation is equal to true. Okay, and if it is false, it won't be giving it won't be performing any kinds of augmentation technique. After that, it will save the model after training it. So here you can see, guys, I'm setting my step per epoch validation step. Then I'm fitting my data. You can see I'm giving the training generator my train data. Then I'm giving the epoch, then step per epoch validation step and validation generator. That means my validation data. After the training, I'm saving the model. That's it. Simple step. The things you used to perform in your Colab notebook, the same thing we are writing inside a class only. Now let me execute and let me show you the model training. So this is my pipeline. So you can see I'm getting the configuration manager, passing it to the training. First of all, I'll be getting the base model. Then I will start my train valid generation. That means we'll be converting our data to training and validation. Then we'll be starting the training. Okay, step of execution we're doing. Now let me start the training. So guys, you can see one error I'm getting. It is telling cannot find the path specified chase cities. Okay, so sorry, actually I was using my previous data location. So here you have to change. So training data location, it is available inside data ingestion, and this is the file name. So chicken fecal image. So let me just write it here. Copy the name, and here let me just replace. Okay, now this should work. Now let me execute. So guys, you can see my training has started, and as of now I'm training only one epoch. Okay, one epoch I'm training because I'm showing you I mean I'm recording it, so like training will take time. That's why I'm showing you only one epoch training. But for you have to train multiple epoch. Okay, at least try to train 300 epoch, then we'll be getting a good model. So here is my loss and accuracy I got, guys. Okay, so it's not bad, 60% accuracy I got. Now if I show you my artifact folder, inside that it has created another folder called training. Now see, this is my train model, it has set. Got it? Now let's try to convert this code as our modular coding. Okay, so to convert to the modular coding, first of all, let's update the entity. So let me open the entity. I'll copy. Then I will update my configuration manager. So this is the method. Let's try to copy. And let me mention it here. I also need to import OS and training configuration. So let me import them. Import OS. Anything else I need? No, I think everything is fine. Now let's update my component. So let's create one file inside component called training. Or I can name it as model trainer. I think that would be better. Model underscore trainer. Okay. So now here I'm going to paste the code, whatever I have written here. So anything else I need the path library, and I also need the training configuration. So let me import. So from path leave import path, then from CNN classifier dot entity dot config entity import training config. Okay, so yes, it's done. Now let me save. Now let's create the pipeline. So here stays 03 model trainer. Fine. So this is my pipeline. You can see. So you can see I'm importing all of the required package. Stage name is training, and this is my pipeline. Okay. So yes, it's done. Now what I will do, I will add it to the endpoint. So let's open my main.py. So let me import this model trainer pipeline. And now let's execute the model trainer. Okay, that's it. Now let me test whether it's working or not. I'll delete that artifact. Now let me execute it again. And this is the model summary, guys. Okay, so these are the parameter, total trainable parameter 50,178, and these are the total parameter of the model. So you can see training has started. Completed. Now if I open the artifact, data ingestion done, PrepareBaseModel done, training is also done. Everything is working fine. Now in the next stage, we'll be creating the evaluation component. Okay, so guys, now let's start the model evaluation part. So for this, I'm going to create a file inside research. Name it as 04 model evaluation.ipynb. Now let me copy the same code just to get back my project working directory. See, if you can only create one stage, rest of the stage actually you can easily create, because you'll be getting the flow. And whenever you are creating the end-to-end projects, you only need to understand the flow. Okay, how you'll be writing the code. So that is what actually I wanted to show you here. So currently I'm inside my project working directory. Okay, so I don't need to update the configuration.yml, because for model evaluation I don't need the configuration. So what I will do, I'll directly write the entity. So this is going to be my entity, guys. You can see a path of the model, then training data path, then all parameters. Okay, from where you will get the parameters, from here you will get the parameter params.yml, then params image size. Okay, then params batch size. So now I'll be creating the configuration manager. For this I need that. And see, the metrics actually I'll be getting, the evaluation metrics I'll be saving as a JSON. So that's why I'm importing the JSON from the utility. So this is going to be my configuration manager, guys. You can see I'm returning the model path. So the model is available inside artifact, inside training, and this is the model. So this is the model path, and this is my training data. And again, I'll be using Keras actually train test splitter. So it will prepare my training testing data, and that data actually I'll be testing. That data will be using for the evaluation purpose. Okay. Now all parameter and image size as batch size. Now let me return them. So now let me create the model evaluation stage. Okay, so here two things you have to import: the TensorFlow, because you can see I'm using TensorFlow, TensorFlow Keras. And another is you have to load the model, because we are doing inside Jupyter Notebook. So that's why I'm directly loading the model. Okay, so whenever we'll be writing the modular coding, that time we'll be reading from the configuration. So now let me import all of them. Then I will load my model. Now this is the evaluation class I have written. First of all, it will generate my validation data for the model evaluation purpose. So it will automatically generate the validation. And this is the method actually it will load the model. The model actually, you can see we have trained. And this is the evaluation function. So it will load the model, it will generate the validation data, then it will perform the evaluation. Okay. Then I will be saving this object in a score variable, and this function will return the score. See, here I'm extracting the losses as well as the accuracy, and I'm saving inside a JSON file. It's a simple one only. So now let me execute. Now finally, I'm going to create the pipeline. That means step of the execution. First of all, get the configuration manager, passing it to the like component, call the evaluation function, then call the save JSON function. First of all, I have to evaluate, then I have to save the JSON. So let me show you. So it is doing the evaluation. Now it has saved. So you will see one JSON file here. So score.json. Let me open that up. So guys, you can see this is the evaluation metrics I got. So the loss, you can see it's 1 point something, and the accuracy 69. Because we only trained one epoch, that's why, but you have to train multiple epoch, then you will see the improvement. So yes, that's how actually we can perform the model evaluation. Now let's try to convert this notebook as our modular coding. So first of all, let me copy the entity and keep it inside entity file. Model evaluation configuration. Then I'll copy the configuration manager. Now let me import it as well. So anything else I need? No, fine. And now the next thing, I'll be copy pasting the component. So let me create a component inside component folder. Model evaluation, or you can also write evaluation, it's up to you. So let me copy the component, whatever component I created in the Jupyter notebook, I just copy pasted here, you can see. Okay, so this is the evaluation class value generator, then save model, load model evaluation function, and save score. That's it. Now let me call inside the pipeline. So let me open the pipeline. Stage 04. So this is my pipeline. Okay, evaluation stage, and I'm copy pasting the same pipeline from my notebook, this one. Okay, so now let's call this thing in the endpoint. So main.py is my endpoint. First of all, I have to import it, model evaluation pipeline, and this is going to be my endpoint. Okay, I'm calling the main. So yes, I think it is done. Now let me execute and let me show you if everything is working fine or not. So I can delete the artifact. So now let me open up my terminal and execute python main.py. So first of all, it will ingest the data, prepare the base model, model training, and evaluation. Okay guys, it's completed. Now let me show you the artifact. See, trainer is done, model is saved, and here you can see the score.json has also created. So yes, that's how we can perform the model evaluation. That means all the component is over. Now next we'll be creating the prediction pipeline, then we'll be creating the user app. So to create the prediction pipeline, guys, so open the pipeline folder, and inside that just create a file and name it as prediction, or you can name it as predict. Okay, predict.py. So inside that, I'm going to create a prediction class. See, I'm importing this TensorFlow. From TensorFlow, I'm importing the load model, because with the help of load model, we'll be loading the model. Okay, the model actually we have trained this model. Then image. From the pre-processing, I'm importing the image. Why I'm importing the image? Because see, user will upload one image, and that image also I need to do some pre-processing. That means here is the pre-processing step. First of all, we'll be loading the image. We'll be converting to the array, because I can't directly pass the raw image. Okay, I have to first of all convert it to the array. Then we'll be expanding the dimension. Then we'll be giving to the model. Okay, so this is the idea. So that's why this image is required. So this is the class prediction pipeline. So it will take the file name. That means user will upload one image. That image actually it will accept, and then it will execute the predict function. So you can see, first of all, it will load the model. It will take the image. This image actually it will pass to the load image function. It will load the image, then convert it to numpy array, expand the dimension, then pass it to the model. Model will give me the results. Okay, and if result is equal to 1, that means it's the healthy image. Okay, otherwise it would be a coccidiosis affected image. Now if you open the data in the Kaggle, you'll see that they have already given you the label. Okay, if it is 1, that means it's a healthy. If prediction is 0, that means it's a coccidiosis affected image. Okay, so this is the simple idea. Now this thing will be creating this thing actually will be writing inside our main file, which is nothing but app.py. So now let's create the our app, user app. So for this we'll be using Flask to create the complete user application. So guys, I think you remember, if you want to use Flask, so first of all you need to write the HTML content, because this HTML page actually it will render. So for me, I already prepared one HTML template for you, so let me show you. So this is the HTML front end I prepared for you. And again, I told you from where actually you will get these kinds of actually templates. So there is one amazing website called Bootstrap. Okay, Bootstrap. So from Bootstrap itself, actually you can get any kinds of HTML and CSS template. Okay, now here I created one simple image uploader. Let me show you. Whenever I will execute, you'll see that simply one web interface I created. There you can upload the image. Okay, and right hand side you will see the prediction. That's it. And this code I will share with you. If you are getting any kinds of project like that, you can use my template as it is. Okay, so it should be present inside template folder. Got it? Now let me initialize my Flask. So let me import all the necessary library. So I'm importing the Flask, you can see, and some required functionality. Then I'm importing decode image from the utility. Okay, now what is decode image? See, I think remember here we created two functions, or decode image and encode image. See, whenever you are uploading any kinds of image, so it's not possible to accept the raw image. Okay, for this, first of all, we have to encode the image, then we have to decode the image. So for this, let me show you one example. So I'll go to the base64 group. So this is one amazing website. So here, first of all, I will open image to base64. So image to base64. Yeah, image to base64. Then base64 to image. Base64 to image. Okay, these two link I'll open. So let's say first of all I will upload one image here. So let's say I will upload this image. This one of my thumbnail image. Now I'll just try to encode operation. Encode means it will create a base64 string for me. See, this is a base64 string, guys. Okay. Okay. Now let me copy, and again you can decode it. So now you can give the base64 here, and you can again decode it. Decode it means it will again create the image from the base64 string. See, this is the image. Okay, so that's how actually we're doing. So first of all, whatever user is uploading, first of all we are encoding it. That means we are getting the base64 string. Then in the backend we are receiving that base64 string. Then we are decoding it. Okay, decoding means we are saving as the image file. Okay, I hope it is clear. So now let me show you. So here I have initialized my Flask. Now here I'll be creating some route. Let me show you. So you can see, guys, this is my default route. That means if user is hitting my application, it will launch the index.html. Okay, here I've given the slash means default route. Then this is my training route. If user is giving /train, it will start the training. Okay, and training is successful. And if training is successful, it will give you successful. And how we are starting the training? We are executing the main.py. This main.py with the help of os.system. Okay, we are running this command. The same thing we perform in our machine learning project as well. Then this is the predict route. If user is submitting the image, it will start the predict route. So first of all, I'm receiving the image. Then I'm decoding it. Why I'm decoding it? Because it would be a base64 string. First of all, I have to decode and convert it to the image. Okay, I think you remember. So here I showed you the demo. Okay, after it will save the image. Then we are using our client app. So here you can see I'm initializing my prediction pipeline, and it will accept the image. The image user is uploading. Then it will give me the result, and that results actually I'll be showing in my front end. Okay, now let me execute my application. So I can remove this part. So port number, let's run 8080. Okay, now let me execute my application. So now let me execute my application. So Python app.py. Okay, it is running. Now let's open up our browser and search for localhost port number 8080. So see, guys, this is my user interface. So let me upload one image. So I'll click on upload. Let's say I will first of all upload one coccidiosis affected image. Now let's do the prediction. See, guys, it is detecting as a coccidiosis disease. Okay, and now if I upload any healthy image, so let me upload any healthy image, and let's try to see. See, it is classifying healthy image. That means healthy chicken. So that's how guys you can create this kinds of web application. And now this application is ready to deploy, but first of all we have to create the Docker file. Then after that we can deploy this application. And for deployment guys, I will use the same deployment process, the deployment process actually we did in our machine learning project. Okay, I think we remember the machine learning project deployment. So the same step you have to perform, only you have to change the like GitHub. Okay, GitHub repository. So there actually I was using my ML project GitHub repository. Now you have to use your deep learning, that is this project GitHub repository. Okay, the same step I perform here, you have to perform the same thing. There is no change. Okay, there is no change. The same step I perform, the same step you also need to perform. I hope it is clear. But before deployment, you just need to do one modification. So if you want to predict in the cloud, first of all you have to get the model. So here is the model guys. So it is available inside training. This is the model. I'll copy, and here I'm going to create a folder called model. Inside that I'm going to keep it. Now here I'll change the location. So inside predict, instead of loading from the artifact, I'll be loading from the model folder. So here I can remove this part. It should be model. Okay, model.h5. Now again you can test whether it's working or not. I'll go back, refresh, then I'll upload. See, it's working fine. Okay, now see, one task I will give you. So this model actually I copy pasted manually. Okay, inside the model folder. Okay, inside the model folder I copy pasted manually. But what you have to do, so after training the model, so here I think in the model trainer, after training the model, so here I can open it up inside component model trainer. So after training it, what you have to do, you have to copy. Okay, you have to copy the model inside model folder. And how to copy with the help of Python code, I think you already know that. So there is a package called Shuttle, I think. Okay, so you can simply search here. Even you can go to the chat GPT and you can simply write how to copy any file in other directory Python. So here is the code snippet guys. You can use this particular package called Shuttle. Now you have to give the source file path. That means you will be giving the source file. That means your model location inside the artifact, and the destination directory, that means in the model. Okay, model folder, and shuttle.copy, and it will copy that particular file. So this code you just need to modify here. Okay, so this task I want to give you, because see, I've showed you the entire implementation, but something I want you to perform. Okay, that's why I've given you this task. So you can perform this task. Okay, so it will automatically copy the model after the training. Okay, in this folder. That's it. So yes guys, now let's create the Docker file, and you have to follow the same deployment process, the deployment I showed you in my machine learning. So that's same deployment video guys I will add, so you can follow and you can deploy this project in the cloud. So now let's create the Docker file. So to create the Docker file, I'll create a Docker file here, and this would be the Docker command guys. Okay, so you can check the Python version. So Python I'm using 3.8, so make sure you are also giving 3.8 Slim Buster image. So first of all, it will install, these are the required, let's say tools. It will create a directory, then it will copy the code, then it will install the requirements, then it will execute your app. Okay, that's it. So yes, I think everything is ready. And in the .github folder, so let's create another file. I'll name it as main.yml. Inside that, you should have this YAML content. That means this is the CICD related command. Okay, so I think I showed you the same file in my email project as well. Okay, so I was using this file to perform the CICD deployment. Okay, the same thing, nothing changed guys. Okay, the same thing. Now let me delete this .git keep file. It's not required right now. Okay, now everything is ready guys. So now you are ready to deploy. So follow the same actually step, whatever step I showed you in the deployment, and try to deploy this project. Okay guys, so now we'll start the deployment, and here you can see I have already added the deployment steps, like what are the things we're gonna perform. You can see first of all I have to log into the AWS console, create the IAM user. Okay, then this is the deployment actually description. Like first of all we'll be building the Docker image of our entire source code, then we'll be pushing this image to the ECR. So here we'll be using some services from the AWS. services will be using called ECR. That means Elastic Container Registry. So here you can push any kinds of Docker image. So this is the alternative of the Docker Hub. I think you know Docker Hub. Okay, there you can also store the Docker image. Then we'll be launching the EC2 machine. EC2 is a virtual machine, virtual computer. Then we'll be pulling this ECR image to the EC2 machine. Then we'll be running that image to the EC2 machine. Okay, then we'll be doing some port mapping. Then we'll be able to access the application. And this is the policy I have to give. Okay, whenever we'll be creating the IAM user. So you can see all these steps actually I have written down here. So we'll be following these are the step one by one. So guys, before starting the deployment, you need one very important you can say file called CICD.yml. And this file you have to create inside a folder. So let me create the folder first of all. So the folder name should be .github. Okay, .github. Inside this folder, you have to create another folder called workflows. Okay, now inside workflows, you will be creating one file called CICD.yml. So this YAML file will help us to do the deployment. Okay, it will execute all the automated command, because here we'll be using GitHub action, okay, as our CI/CD tool. And for this, we need this file actually. And the folder structure should be like that. First of all, .github, inside that workflows, inside that CICD.yml. And these are the command you have to mention here. And now you can ask me where I got this command. Just simply search on internet how to do the CI/CD deployment with GitHub action AWS. You will get this CICD.yml file, okay, from the GitHub site, and you can copy paste the same thing and you can do some modification. So what I did some modification here, and rest of the things I keep it same. So it will perform the continuous integration, then continuous delivery, as well as the continuous deployment. Okay, I'll tell you what will happen whenever we'll be doing the deployment. As of now, just try to remember this is the thing you have to do. Now you have to mention the port here. I think you remember we are running our application in port number 8080. That's why we have given port number 8080. If you are using any other port, you have to change the port number here. Okay, yes. Now, see, before starting the deployment, guys, first of all, I will tell you what is CI/CD deployment exactly. For this, I already recorded one video previously. I'll add this video part in this video. This will give you the entire understanding what is CI/CD deployment and why we need it exactly. Okay. Then after that, we'll be starting the deployment. So guys, as I already told you, here we'll be doing something called CI/CD deployment, right? And I already told you what is CI/CD full form. It's continuous integration, continuous delivery, or deployment, right? So inside continuous integration, continuous delivery, what happens? Let's say you are the developer. Okay, let's say you are the developer. So what is your task? Your task is to develop a project in the development, let's say, environment. So development environment means like your local system. Let's say you are using your laptop or computer. Let's say local computer. Okay, local computer. Fine. Then what we are doing, I think you remember, we are committing this code to the GitHub, right? We are doing the code management. I think you remember. That means whenever I was adding some new feature, I was pushing this code to the GitHub. Yes or no? Okay, with the help of Git client, we are pushing the code in the GitHub server. Now what happens actually, let's say after deployment. So this is called actually development server, or I can write this is actually development environment. Okay, development environment. So after implementing this project, what we have to do, we have to deploy this project, yes or no? Let's say somehow you have deployed this project on the AWS cloud. Let's say this is your AWS cloud. Fine. So let's say you have deployed this project to the AWS cloud. Manually you just created a, let's say, instance there. You just took a machine there, a EC2 machine, and you manually deployed this project. Now it will give you some endpoint. Okay, endpoint. So with the help of this endpoint, any of the user can access your application. Now let's say after 4 months, or let's say 6 months, you want to add some more features in this, let's say, application. Let's say you are deploying medical chatbot. The medical chatbot we implemented, I think you remember, right? Let's say you want to add some more data, you want to add some more knowledge base, and you want to add some more features in this application. Then what you have to do, you have to again develop this, let's say, features in your code. Then what you will be doing, again, you will be deploying this application to the AWS cloud. Now just try to see, whenever you are deploying the project for the second time, let's say this is the first time you have deployed, then you are trying to deploy for the second time. Then what you have to do, first of all, you have to stop this application in the AWS. Okay, stop this application. Then you will be uploading your updated code. Then this code will reflect to the endpoint. Then user will be able to access that. Now let's say in between, whenever you stop this AWS server, let's say your application, let's say it took 3 hours. It took 3 hours to change the entire source code. That means change the entire features, okay, of your application. So what will happen? 3 hours user won't be able to access your application. So they will come your website and they will see server error. Okay, server error actually they will get. So if user is getting this kinds of experience, so definitely it would be a negative, let's say, effect, okay, on your application. So next time actually they are not going to use your application. Yes or no? Let's say if ChatGPT is down for the let's say 3 hours, definitely people will move to the Google Bard or any other, let's say, software, whatever actually we are having. Okay, so now see, ChatGPT is also updating their, let's say, application day by day. But did you ever observe this server is down? No, you are not seeing this server is down, but still they're able to make the changes in their application. How? Because they are following something called CICD approach, continuous integration, continuous delivery. That means this application is keep on running, but in the backend they're pushing their source code, they're pushing their, let's say, new features, and this feature is automatically getting updated. Okay, so this is called actually CICD. That means you are not going to deploy this application manual. Instead of that, what you have to do, you have to follow the CICD. That means what will happen? Let's say you have changed something in your code, you will push the code to the GitHub. Okay, GitHub will automatically let's say deploy your code to the AWS cloud. It will automatically push your code to the AWS cloud, and your endpoint would be automatically updated. Okay, automatically updated, so that if user is using your application, okay, they won't be feeling any kinds of, let's say, server down issue. Okay, server down issue actually they won't be feeling. Got it? So this is what actually we have to do. That means we'll be creating the entire pipeline, entire, let's say, CI/CD pipeline. So we'll be just pushing the code in our GitHub, and GitHub will automatically trigger this action, and my code will update it to the AWS cloud, and AWS will update the endpoint. Okay, now see, the automated process we'll be doing now. Whenever we'll let's say push our code to the GitHub, GitHub will automatically trigger. How it will trigger? For this you have to use some CI/CD tool. Okay, CI/CD tool, CI/CD automation tool. So here there are different kinds of CI/CD tool. So the first tool you can use something called GitHub Action. Okay, GitHub Action you can use. Then you can use something called Jenkins. Okay, Jenkins. Then you can use something called Circle CI. Circle CI. So these actually three famous tool actually we are having in the market right now. So people are using more this GitHub Action, because GitHub Action you don't need to set up anything. It is already set up everything in the GitHub. But if you're using Jenkins and Circle CI, you have to set up this server manually. Okay, so here we'll be using GitHub Action because it is already inbuilt with the GitHub. We don't need to set up anything. Going forward, I will also show you how we can let's say use Jenkins, Circle CI. These are the services as well. Fine. So yes guys, this is the complete high level architecture of our deployment. So guys, I think you saw what is CI/CD deployment and why it is required. And now let's start the deployment. But before that, let me give you some high level walkthrough of this file. See, inside continuous integration, I'm not doing anything. I'm just only doing the echo operation. But going forward, if you are running any test cases, you can execute the test cases inside continuous integration. Inside continuous delivery, I'm just authenticating with my AWS account with the help of AWS access key and secret key. I'll tell you how we get it. And after that, what I'm doing, I'm building my Docker image. Okay, with the help of Dockerfile. It will build the entire Docker image, then it will push this Docker image to the ECR repository. Okay, then inside continuous deployment, I'm again you can say authenticating with my AWS account with the help of this credential. Then I'm pulling my Docker image inside my EC2 machine. Okay, then I'm executing here. Okay, and then after that we'll be doing some port mapping and we can access our application. This is the high level walkthrough. Now let's go back to my AWS. So I already have one AWS account, guys. If you have account, please try to log in with your account. And if you don't have account, try to create one account. So the first thing what you have to do, you have to create one IAM user here. So let me create one IAM user. So you can simply search for IAM. That means Identity Access Management. That means you are not going to give all the permission of your AWS account. Okay, because you need some certain services here. So we'll be only giving that particular permission. Okay, that's it. I'll just click on the user and let's create a user here. Now I'll give the user, let's say, ML project. You can give any name, it's up to you. Now let's attach the policy. So here I already added the policy, what policy actually you need in the README file. So here I need two policy. One is the EC2 container registry full access, that means ECR. And this is the EC2 machine. Okay, so simply starts here and just try to tick mark it. Okay, once it is done, just try to remove and again give the second permission. So search here and try to give the permission and simply click on the next. I'll see that two permission I have added. Now I'll create the user. Now user is created. Now click on the user, go to the security credential, go to the access keys, select command line, and I understand the above recommendation. Click on the next. After that, create the user. And this is your access key and secret key, guys. Okay, now you can download it as a CSV file as well, so that I need later on. Okay, so yes, and don't share this key with anyone, otherwise they will be also able to access your account. Okay, so I'll remove it after the recording. That's why I'm showing you. So it is created. Now you can see this first step we have done. That means we have logged into the AWS credential. That means we have logged in our AWS account. Then after that, we created the IAM user, okay, with the permission we have given. Now the next thing, I have to create the ECR repository. Okay, so to create the ECR repository, search for ECR, Elastic Container Registry, ECR. So this one. And make sure you track your region. Okay, see, I'm working in the Mumbai region. If you're using any other region, you have to give the region ID. Okay, so here I'll be using AP South 1. Got it? So create the repository. So you can give any name. Let's say I'll give ML project. Keep it everything default, no need to change anything. Create the user simply. Okay, and copy this URI and save it somewhere because I need it later on. So let's say I will save it here as of now. Okay, now the next thing, I have to create a EC2 machine. Okay, Ubuntu machine I have to create. So for this, here you can search EC2. That means virtual machine, EC2 instance. So simply just click on launch instance, give the name, let's say ML machine. You can give anything, it's up to you. Select the Ubuntu. Then after that, you can select the instance type. Let's at least take 8 GB memory, guys. Okay, 8 GB memory you have to take. So let's take T2 large. And after that, select the key value here. If you don't have a key value, you can also create. Let's create ML project. So this key value here you need. Let's say if you want to access your machine with the help of any third party, let's say a tool, let's say Mobile Stream or Putty, that time actually you need it. But here I'm not going to use third party tool. I'm going to directly launch the like AWS CLI. Okay, from there actually we can access our machine. I'll tell you how to do it. Then after that, select these two options, HTTP and HTTP, and select the configuration storage. At least take 30 GB. After that, let's launch the instance. So click on the view instance. Now it should be running. Just refresh here. The status should be running. Now guys, you can see my status is running. That means my machine is running. Now click on the machine ID and click on the connect button and simply connect. Okay, it will open a new window and there you will get one black terminal. And this is your production server. So guys, you can see I got the terminal. Let me zoom a little bit. Now let me clear. Okay, now here you have to set up some of the tools. So here I have already mentioned the command. So these are the command you have to execute. First of all, let's update the machine. Okay, then I also need to update the apt-get update. Give the yes permission. Okay, it's completed. Now I'll copy this command. Now we'll be installing Docker, okay, in my machine because Docker is not there by default. So for this, you have to execute this at the command. Okay, so next command. Now I think the last command we have to execute. So these are the Linux command. Now it's done. Now if you want to test whether Docker is running or not, just write Docker ---- version. So it will show you the version. Okay, if showing the version, that means Docker is running successfully. Okay. Now the next thing will be configuring this EC2 as our self-hosted runner. That means we'll be connecting our GitHub with our AWS. Okay, that means whatever, let's say, commit will be doing in my GitHub, okay, it will automatically let's say push to my AWS cloud. Okay, for this, what I will do, I will open up my GitHub repo. Make sure you are using your repository, not my repository. Click on the settings. Now here you will see one option called action. Now runner. Now here you will see self-hosted runner. Just try to click here. Select the Linux machine and you have to execute these are the command. Okay, till configure. So let's copy one by one and let me execute here. Okay, so this is the command. Now I'll go to the configure and copy this command and let me execute. Now I'll see that it will connect with my GitHub, okay, with help of GitHub action. Now see authenticating GitHub. Now it is asking for the name of the runner group. I won't be giving anything, just press enter. That is asking enter the name of the runner. You have to give self hyphen hosted. Okay, make sure you're giving the same name, otherwise it won't be working. Now it is asking for the label. I'll skip it, press enter. Then again I'll press enter. Okay, now press enter. Now see, it is done. Now let's connect the GitHub. So for this, let's copy the last command and let me execute. Now see guys, connected to GitHub and listening for the jobs. That means connection is done. Now if I check the connection, just go to the runners, you'll see that it's ideal. That means my GitHub is connected. Okay, it's up and running with my AWS. Now whatever change I will be doing, it will automatically get updated. Okay, but before that I also need some security credential. Okay, with the help of credential it will authenticate with my account. So here I already mentioned, after that you have to add some security. Okay, secrets. So let's add the secret. For this, left hand side you will see secret and variable. Go to the action and repository secret. Okay, create a new repository secret. First of all, give the all the list I have given. So copy this one, AWS access key ID, give the key name, and here you have to give the secret. And where you will get the secret, I think remember we downloaded one, this access key. Okay, whenever we created the IAM user. So let me open it up. So this is my secret. Okay, AWS access key ID. I'll copy. Make sure you're copying before the comma, because it's a comma separated, right? So this is my access key ID, and after comma this is my secret access key ID. So I'll copy and mention it here. So don't do any mistake, otherwise it won't be working. Okay, try to follow the exact step I'm doing. Now create a new repository secret again. Now I have to add the AWS secret key ID. I'll copy and I'll paste it here. And this is my AWS secret access key ID. Before the comma, let me mention. Now new repository secret. Next one, AWS region. So here I was working in the Mumbai. You can see I'm Mumbai, and Mumbai ID is AP South 1. So let's give the name. It should be AP-South-1. Okay, make sure you are giving the same name. And if you're using any other region, you can give the same ID here. So it's done. Now let's give the ECR login URI. Copy. Now what is ECR login URI? I think remember we copied one URI, right? This one. So copy till .com and try to paste it here. And make sure you are giving your one, guys. Okay, not my one. Otherwise, it won't be working. Now the next one I'll be creating ECR repository name. And what is ECR repository name? So here you will get it. So the last one after the /ml project. Done. I think nothing is there. Now let's start the deployment. Okay, so I'll go back to my repo. Now simply I just need to commit my code. So let's commit CICD edit. Okay, done. Now if I go back to my GitHub and refresh here, you'll see that your action would be running. Okay, there is a yellow mark. Now go to the action and CICD is added. It's running. Now see, continuous integration is running. Continuous integration is already done because here I was doing the echo operation. Now continuous delivery is running. Now let me open it up. See, first of all, it will install all the required packages. Then it will authenticate with my AWS. Okay. Then after that, it will build a Docker image and it will push the image to my ECR repository. So this process will take some time. Let's wait. Once it is complete, I'll come back. So guys, as you can see, my delivery is completed. Now, if you go to the ECR, you'll see the image actually it has pushed. So let me show you. If I go to the Elastic Container Registry, see, this is my ECR has been created. Now inside that, this image has been updated. Okay. Now the next stage is running continuous deployment. So what will happen now? It will again authenticate with my AWS cloud. It will pull the image from my ECR and it will run in my EC2 machine. Okay. So guys, as you can see, my continuous deployment is also completed. Now what I will do, I will get back. And here you will see one public IP address. Just try to copy and just paste here and see if I execute. See, it won't be working because I have to set my port. Okay, because my application running port number 8080. Okay, so how to set this port? For this, just go to the security and here we will get one option called security groups. Then click on this edit endbound rules. Select this custom TCP. I have to add the rules. Then I have to select the custom TCP and port number 8080. Give the 000 and save the rules. Okay, once it is done, get back to the instance. Now copy the public IP address again and try to paste here and give the port number 8080. Okay, now it should work. See guys, my application is running. Now what you have to do guys, first of all, you have to train the model. I think you know. So to train the model, give the /train. Guys, you can see training is successful. Now I will go back. Now I can do the prediction. Let's give the number. You can give any number. I'm giving, so you can give the actual number. I'm giving the dummy value just to test whether it's working or not. Okay, after that, I'll click on the predict. Okay, I have to give this number as well. You can see this is the quality of the wine. Okay, that means everything is working fine. Now let me show you how we can destroy all these instance you have created. Let me show you the termination. Otherwise, it will charge you. Okay, if you keep on running this. So for this, first of all, I will stop the instance. Select the instance. Click on the instance type, instance, and click on the terminate. Okay, terminate means it will delete after some time. So it is shutting down. After some times, it would be deleted. Now, similar wise, I also need to delete my ECR repository. And delete. And one thing, let me tell you, see, whenever your application is running and if you are adding some new feature, okay, next time, so you have to execute this, you have to uncomment this 3 line. Okay, this 3 line, what it will do, it will first of all stop the current running container. Okay, then it will, let's say, launch your new container. Okay, so make sure whenever you are pushing second time, that means the second time if you are pushing, you don't need to do the configuration. It's just a one-time setup. Okay, so it will automatically update your application in the AWS clouds. But before that, you have to activate this 3 line. Okay, I hope it is clear. Now let me show you how to delete. Yeah, so it is already deleted. Now I will be also deleting the IAM user. User ML project. Just try to delete it. Give the name. I'll copy and here let me paste. Okay, see, everything is deleted. Yeah, so guys, yes, that's how actually, so yes guys, that's how actually we can do the CI/CD deployment. See, next machine learning project implementation, we'll be learning some advanced topic. So there actually I'll show you how we can use different kinds of MLOps tool as well. So yes guys, this is all from my side. I hope you liked it. If you liked it, so please rate the codes. With that guys, thank you so much